Hello, everyone. Welcome to another live stream edition of Azure User Group Manila. My name is Marilyn Svenovi, and this is feels like kind of new to me. It's been a while since I went on live. It's been a while since we had our last virtual meetup. I think it was back in May when we did Global Azure Philippine edition. So, and I just came back from summer vacations. So suddenly this feels new to me and it's very exciting. But hopefully everyone out there watching us having a good time. If you are here in maybe Western Europe on CET, then good afternoon. Hope you're enjoying your lunch. And if you are in the Philippines right now, because most of our audience is in the Philippines, then I hope you're enjoying your, I don't know, your break, your dinner. So good evening to all of you. So, today we have a very exciting topic. Actually, we just spent about 10-15 minutes before we went live talking a lot about the latest updates in the Azure AI world. And we had a lot of super interesting discussions, Michael and I, like always. And I feel like if we sat together in real, then we can end up, hours and hours just talking about Azure and the latest development in data and AI and technology. So I'm super happy that uh, you're here with us, Penny, Michael. How should I
Yeah.
address you? What's your
These days, MJ na tawag sa akin eh.
Wow, MJ. So I
Yan.
better get used to it. You're like me. I also had so many nicknames. I have different nicknames
Mm.
from back in college and then nicknames when I started working, nicknames when I was young. So MJ, thank you for really reaching out and volunteering your time to help the community learn and discover everything about vector databases and what's new with Azure AI and Azure Cognitive Search and OpenAI, super, super hot topic and something that is very disruptive, something that's going to change or is already changing our lives. And we're really interested in learning more about it. 1 hour is not enough, but I hope this introduction will be very helpful for everyone. And then what we would like to do is to maybe, hopefully, find time, also maybe from MJ or other experts out there, to form a series of live streams and discussions about Azure AI because I just really feel like sometimes meetups like this for 1 hour, you get just tiny bit of it, and that's not enough. So if we really want to succeed, especially in this topic, we need a bit more time. We need more experts to help us. So if you're interested in Azure AI, you have something to say, you have knowledge to share, please reach out and yeah, get in touch, and then we'll put you on our live stream. All right.
All right. Thanks very much, Marilag. Again, very happy to be back now. Again, I think it's the perfect sequel from my previous talk. No? Same, I guess, same audience and same kind of like ecosystem way back in May. And like, actually, May, June, July, August, September. It's been a while, right? 5 months or something. That's like forever. It's like 5 years in what just happened in this industry. So very
Yeah.
excited to actually share a lot of my insights and experiences, with this topic and this set of technologies. So,
All right. Looking forward. So I'll give you the stage. I'll share your screen here.
all
Have
right.
fun.
Cool. All right. Thanks very much, Marlag. All right. So, hi, everyone. Yes. So, I'm MJ or Michael John Pena. Just a quick intro. No. Lately, or my current affiliation is basically I work for a company called Playtime Solutions as the technical director for data engineering. So basically, we're an Australian-based company, and we cater with a lot of these data engineering problems. And yeah, like this OpenAI is kind of like really hot here in Australia at the moment. And then I have a lot of things to unpack with this talk now. Um, but I guess I'll start with where I left off from the last talk. So for those who didn't watch my previous talk, basically I talk about Azure OpenAI and like what are the emerging patterns and like different kind of like approach on how to use OpenAI and stuff like that. And one of the thing that kind of like emerged from my talk is the concept of RAG, or what we keep saying as retrieval augmented generation. So if you work with not just OpenAI, but ChatGPT, right? Like most likely you've already played with ChatGPT one way or the other. Um, it turns out that in the enterprise or in the industry setting, ChatGPT is not the real kind of like not the only solution to the problems that they have. So what I meant was that because back then for me, I was thinking like ChatGPT is kind of like a solution looking for a problem, and then now fast forward to now like September. Now there are a lot of problems that you can actually apply ChatGPT's of. But then for those who've already crossed the path of like, hey, why would I be using ChatGPT? Like I kind of like they've already crossed that path wherein they've already identified why they want to use generative AI. Maybe they want to generate documents, maybe they want to summarize contents, or maybe like there's a bunch of like emails or documents or you know information everywhere that you just kind of like want to kind of like summarize and make sure you're when you talk to a kind of like a bot, making sure that it's actually generating a human-like experience when that bot is talking to you. So RAG, it turns out it's actually one of the, if not, it's the only approach I'm seeing at the moment that really won or is winning with this OpenAI space. So meaning, so basically RAG is that if you look at it, this is your application, right? And then that app talks to a backend. So obviously, the app doesn't talk to the OpenAI API straight away. You have to talk to a backend. Basically, what happens there is that RAG allows you to, hey, what if I don't necessarily just have to talk to OpenAI to get my information? Because for two main reasons, right? Number one, OpenAI is probably GPT models in particular. They're only trained until July 2021 or August 2021. So meaning anything that happens after that one, it's not really relevant for you, right? And then second is that it doesn't really have access to your data. And you probably don't want to, right? Like you probably don't want to, create a model on top of the GPT model. Maybe you don't want to do that unless your data set is really really big, right? But um, for an ideal scenario, it's very less likely that you'll actually be fine tuning, as we keep on saying, the GPT model. So the approach that you might actually be using is doing RAG, meaning like you talk to an indexing or searching capability, such as Azure Cognitive Search. And then from there, it actually augments the different databases, different data sources for you. And then you're still using the Azure OpenAI to actually generate the content for you. So meaning if you try to talk to now let's say your SQL database or Cosmos DB, then that's where you actually look for your for the information that you're actually looking for. But then you're still leveraging Azure OpenAI ChatGPT experience. So actually making sure you have a very fun or intuitive, personified or prompt engineered response, right? So yeah, like RAG seems to be the approach at the moment. That's kind of like winning. So for this thing to actually work with RAG, Azure Cognitive Search is actually very important for two main reasons. Um, Number one is that it's has the it's even before the OpenAI space and stuff like that, it already has the capability to index relevant data sources, right? Meaning, like for example, I want to index a document or a blob storage or something like that. That already exists in previous years, even prior to OpenAI, Azure OpenAI. But second is that they've now introduced a vector capability within Azure Cognitive Search, which kind of like the topic that I'll be really drilling down today. And again, it's a very very exciting um, topic for me because like I've been, I was talking to Mary like earlier, like I've been trying to swim my way in this Azure OpenAI space, and like one thing that really clicked on me is this vector database stuff, right? And I think this is really where I want to specialize in, because I'm seeing it's kind of like, if you look at the ChatGPT LLM hype, this is like the hype on top of the hype. Like this is where because this is very um, again, it's not a solution looking for a problem, because it's an actual solution to existing problems, which are really hard problems, which I'll be digging in the next couple of minutes. So that's basically RAG, right? Again, just to recap, the app talks to your servers, gathers information for you, making sure they're relevant, and then yeah, like still using OpenAI ChatGPT experience to do a response for you. But now let's talk about search. So what is search really? And then what are the different search, and like why are they kind of like relevant for ChatGPT? Well, first off, it turns out in my experience, or at least the projects that I'm exploring at the moment, is that ChatGPT or the LLM, or like how good the English is or how good the presentation is, it's not really the problem. The problem is how relevant is the information presented to me, right? Because the thing is, if you most of the search capabilities at the moment use something like keyword search. So what that means is that when I type in, for example, Azure, right? So it's actually gonna look for exact match of Azure, right? But it's not really contextually aware that Azure also means cloud computing, or it also means managed platforms, or there's platform as a services and stuff like that. So basically, keyword searching is kind of like the norm at the moment. We're in, like, if I'm trying to look for information, so in the chat GPT scenario, right? If I type in this, then it's gonna look for certain keywords, look to the database and say, oh, right, I see you. So you mentioned this specific word. Now I'm gonna traverse through my database, and then like, present it to you based from the exact keyword that you asked me. However, the the thing that's kind of like emerging in this space is that it turns out that, because of, again, the problem that I presented to you earlier, that not really problem, but like the contextual awareness of like Azure could really mean a lot of things. Same thing with when you say something like capital, right? Capital can mean a bunch of different things, right? Is it a capital letter, capital of a state, or a capital crime, or so many definitions, right? And the thing is, it lacks context, right? And if it's lacking context, then the user experience for that, generation of the response is very kind of like lackluster, right? It's not very contextually aware of like, what do I really want? And that's where it becomes frustrating, right? Like if you're actually searching for information and like in your head you kind of want this, and it's generating something else, like that's the frustration is. That's why, you know, um, that's why this thing called vector search is kind of like what's emerging at the moment, and this semantic search. So vector search is basically, instead of actually using rows and columns, in a traditional database, whether it's relational or NoSQL, um, it actually uses vectors. So, and this is also kind of like fun for me, because I've actually studied vectors. If you've taken calculus back then, vectors is actually one of the things that are being taught back then, and like the whole sine, cosine, and stuff like that. And then the thing is, like fast forward 20 years since then, now I can finally apply that. Um, so there you go. So the thing is, with vector search is that instead of actually looking for exact match of the word, it's actually looking for like vector proximity. Like, think of it like there's a vector space out there, and then this is your the information that you're looking for, and then like it's trying to look for like like near information that's kind of like relevant to that. So for example, what I mentioned earlier about capital, right? When you say capital, oh, it could mean this, it could mean that, it could mean this, it could mean that. So it's trying to look for those relevance, right? Instead of just searching for the exact word, right? And then The thing with semantic search is that besides using vectors, it's now using NLPs, which is like basically a machine learning technique to understand and kind of like do more semantic relevance to the query. So I'll do that more. I'll explain it more later in the demo so that you can kind of like understand the difference between plain vector search and like what's semantic search. Okay. But first, like just review yourselves again in terms of data structures, right? So key value pair, dictionaries and stuff like that. Like this is the key, this is the value. And then document approach, like if you look at something like Cosmos DB or Document DB, um, you're basically like, hey, here's the index, and this is kind of like the document that I'm pointing into. And then if you're using graph, then it's like, hey, here's the parent, here's the children, and then the children of the children. But with vector database, it's basically like, hey, there you are, and there you are as well, and there you are. Like you have an actual place within that space. You kind of like live in that space, and like this one, how near are you from this guy, and then how near are you from this guy, and that's how you kind of like relate or like try to understand the relevance of that you know um, information that you're seeking for. Again, like for example, capital would, if you type capital, like there's the likelihood that it means this is that, and then this one, and so on and so forth, right? So instead of like looking it in a graph or document or key value pair, it's actually just like scattered around, and there's like a proximity distance, or as we keep on, we call it score, to actually determine how relevant are you with that kind of like information that you're looking for. So the thing is, so for you to actually understand how vector database works, you need to understand how embeddings or vector embeddings actually work, or what does it mean in the first place. So again, right, like these are like this is a vector database, right? And then this is, think of it like any source information, like whether it's text, video, or audio, which is actually one of the reasons why it's an emerging kind of like um, approach or technique. Because again, right, like if you look at audio and video, if you're trying to use keyword search, how does that gonna work? It's gonna be hard to use keyword search for images or videos, right? So that's why embeddings or like vector databases is probably the way to go to actually look for similar image, similar video or similar audio, right? That's why again, this kind of like emerging data store is very relevant at the moment, because now we have these capabilities, we now have this compute power, we now have the cloud to actually generate kind of like give this kind of like capability to us. You don't actually have to start from scratch anymore. So we've crossed the path of like a data science problem or like an algorithm problem into now, hey, it's an actual platform. It's an actual service that you can actually use it for. Um, so basically, what happens here is that the image, audio, and video, and the text, you transform that into a embedding, right? A vector embedding. And the thing is, with there, right? You actually use a model, something like text embedding ADA 002. And contrary to what people might have thought about OpenAI, that they just think that OpenAI is just ChatGPT or maybe DALL-E. But one of the really good models that they have as well is this text embedding ADA 002 that actually allows you to convert any of this image into a vector embedding. Like that means that you don't have to create your own algorithm anymore to say that the word capital is -2, 1, 4, 5, 6, and stuff like that. This model, the text embedding ADA, is the one who's gonna kind of like translate that for you. Okay, so that's why it's very powerful at the moment. And then using Azure Cognitive Search, right? So the thing is, you know, first is you need to index this, meaning you have to register all these vector representations that text ABC is this vector representation, like video ABC equals this vector representation. So in that regards, the Azure Cognitive Search becomes a data store of the actual embeddings of the vector, right? And then that's probably why you in the future you'll actually see more and more of these emerging databases around, like, hey, we're targeting vector database, we're doing more of this vector stuff, right? We can host your vectors pretty much. Like that's kind of like what's gonna happen in the next couple of months or probably years. And then the thing is, when you do a cognitive search, you actually try to, like, hey, here's the vector that the user is actually looking for. Now try to compare that to the vectors that or the embeddings that I've indexed already within cognitive search. So kind of like cognitive search is the one that kind of like perform the queries of these embeddings for you, right? Like if the user is looking for an Azure service that does this, then it's gonna look through the vector data store that it's at approximately near that that query, which I'll show you later on in the demo. All right. So if you might ask, like, what if I'm not into Azure? Like, because it is very important, right? It's because what if I don't want to use Azure Cognitive Search? So what are the other options? So there, you'll be surprised, or maybe not, if you're already doing a lot of this RAG stuff. But there are a bunch of vector databases already at the moment, and like they're the ones really kind of like, again, told you earlier, right? The hype within the hype. They're kind of like within that space. These are like the newcomers. Chroma, Quadrant, and Milvus. They're like open source, and then most of them offer something like an enterprise tier, or like host on your cloud or something like that capability. These are like Pinecone and VB8. They're more like commercial, um, and like source available, but kind of like commercial. And then something like Redis and Elasticsearch, they're actually exploring this kind of like space as well. Same with Postgre. So actually, Postgre is the one that's they actually looked in the very beginning when I was curious about this vector search, because they have this thing called PG vector. So yeah, it's like, well, again, it's something that's similar, but you have to maintain it yourself. So that's one of the, I wouldn't say downsides, but one thing you just have to be kind of like one of the considerations that you have to look at when looking at these different vector databases, right? Like how much of it is like I have to maintain and manage, like what's managed and what's not managed. So and that's why Azure Cognitive Search kind of works for me or for us at the moment, because a bunch of these are already managed for you. Like like storing this and like the capability to perform search and stuff like that. Yeah, it's all managed for you already. So with that, I'll now go to the demo of this talk, so that you actually see vector databases in action. So for that, I actually created a okay, so I created this thing called a polyglot notebook, right? Um, in C sharp. The reason why I did this in C sharp is because, one, I really love C sharp. Second is that there's lack of samples in the data science, data engineer world in C sharp. Mostly they're in Python. I don't hate Python. I actually love Python, and actually the polyglot experience, or like the notebook experience, is the one that actually helped me learn Python when I was actually trying to do machine learning in computer vision like a couple of years ago. And I kind of like really like this approach, especially doing demos and like explaining to people like how this thing kind of works, right? So in this notebook, basically, I kind of like explain what's a vector database and what's Azure Cognitive Search, which I already mentioned earlier. So in this flow, basically, first I'm gonna initialize the following: the service endpoints and the keys, NuGet packages, references, C# clients. The thing here is that even though I'm exposing a bunch of this will be gone in a couple of minutes. I already set them to auto destroy in a couple of minutes, so making sure it's not gonna happen within the next hour or so. But yeah, like but I want you to give an idea that these are what you need actually. First, you need to go to Azure portal and create a cognitive search. So you need the endpoint, and then create an index name that you want to call it. And then you need the key from that cognitive search. And then you need the OpenAI endpoint and the key, and then the embedding model from that OpenAI, which again I told earlier, text embedding ADA002. And then how do you config name, um, and just different configurations. Um, and then how many results do you want to show based from the search that you're doing. So first off, you just have to reference Azure AI, OpenAI, Azure Identity as well, because obviously you need to log in, and then Azure Search Documents. So the same NuGet package that you already use doing, the Azure Search, that's something, same thing. You'll be just using that. But I think the semantic search is not yet available in the LTS, so it's still in beta at the moment. Then a bunch of other usings for you to use. So, and then basically just have to initialize an OpenAI client. So again, if you're in C#, it's very, love this language. Like it's very easy to understand. Credential equals new credential. OpenAI client equals, OpenAI client. And now I have an OpenAI client that I'll be using, to talk to Azure OpenAI. And then same thing with search client and indexing client. But basically the search client is within the indexing client. So yeah, like they're actually both within the search index client, but it's I kind of like want it to be like separate, that I'm doing indexing and I'm doing searching. First off, you need data. So for this activity or for this demo, I have this data, which is an Azure.json file. So basically, it's just a local file for now, which is basically around 200-ish content. So the idea here is that it's a bunch of Azure. Um, and I'm just gonna zoom in real quick. But basically, the idea here is that it's a bunch of Azure services, like app service functions, Databricks, like your Servium instances, Service Fabric, um, Bastion, Data Factory, and stuff like that. So this is kind of like my data set that I'll be working on, right? Like, and what I did is that first I created the search index. So again, I registered the this Azure JSON to cognitive search. So the way I did that is first you need to kind of like create a vector search, and then semantic settings. So basically within the semantic settings, all you gotta do is that you have to declare what's semantically relevant that you want to search for. So for example, it's like title is a title field, like content is like the content. Um, property, and the category is more like a keyword. So a keyword is something like tags, like something sortable, or like something you can kind of like filter down. Um, so yeah, so basically I have a title, a content, and a category, right? And then within the fields, I have the ID, title, content, and then I created a title vector, a content vector. So this is kind of like the juice of this kind of like capability, right? You now created a search field, which is a title vector. So you're basically registering the titles as a vector embedding. So which I'll kind of like show you the the response or like the values of this later on. And then searchable field, which is category. You don't necessarily have to vectorize the category because you kind of already know them, right? Like, you want to call it developer tools or management governance or web or database and stuff like that. So it's not worth vectorizing that because you're not really traversing within category. You're just traversing within the content and the title. So that's what you're kind of like looking for relevance, not the category. So basically, you just have to create a search index first. So meaning this is kind of within the Azure Cognitive space. This is the let me just open that real quick. So if I open the Azure Cognitive Search, I mean, um, basically this one, right? Like there, it comes with, this is what you really do, right? You do indexing, right, within Azure Cognitive Search. You can basically add an index, and instead of doing it in the portal, I just did it through C sharp. So it's kind of like the same thing, right? And then the idea is to populate, the content of that index. And yeah, I mean there are a bunch of things you can also do within Azure Cognitive Search. Whether you want to attach data to, again, blob storage or Cosmos DB or other stuff. Um, and then what happened next is that I deserialized the input, the Azure.json stuff, and then I basically just like the rest of the code is that I registered all of that within the Azure Cognitive Search. What is interesting though is that this generate embeddings, which I was talking about earlier, right? So for the content embeddings, right, the content, I created the embeddings for that, meaning that the content, right, this thing, like the Azure Cost Management, blah blah blah, that's actually what I'm storing in Azure Cognitive Search as a vector, um, uh, embedding, right? So what that means is that when I did this, if we go back to Azure portal, right? So within that, if, for example, let me just explore, Azure, um, which is pretty much everything. So if you look here, right, the content vector, you'll see there, right? This negative 0, 1, blah, 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 1, like all these different kind of like coordinates and stuff like that. That is the vector embed of the content. So, right, instead of actually just storing the content, you're actually translating that into a embedding. And again, as part of that, I used the text ADA 002 to actually convert the this content stuff into those embeddings. So that's it, right? Like if you think of it that way, right? You're not actually storing this actual content here, meaning sorry, the actual words here, right? You're actually translating these contents first into an embedding, and then you use a vector database to actually store those embeddings. That's just really it. If you think of it that way, right? That's what a vector database is. It's a database of embeddings. It's a database of these vectors. So and then Azure Cognitive Search allows you to, instead of just storing these vectors, now it allows you to actually search and perform, index first and then perform search. And that's kind of like the power of the Azure Cognitive Search. So once all of this are already registered to Azure Cognitive Search, meaning you've already created an index. So just going back here, right? So I do have 108 documents, so meaning all of the Azure.json contents are already registered here in this index. So that means that, hey, I can now perform search, and that's where the magic will happen. But before that, I want to just show that, hey, there's this semantic configuration, which is again kind of like very important, that you need to have a semantic configuration to kind of like tell cognitive search that, hey, I'm doing semantic search. Um, so if we go here, right, because I already um, did that, let me just minimize that one. So otherwise, if you guys want to wait for another 5 minutes or so, or probably 3 minutes, yeah. So indexing actually takes time as well. So that's one thing you have to consider as well. So if you want to index the whole, your whole SharePoint site or stuff like that, you need to have a proper ELT process first before actually indexing everything. So, classic saying, garbage in, garbage out. So you have to clean what you want to index first. So make sure you don't just index everything. Or maybe you do, but it's just going to take time. All right. So first off, I'm going to perform a single vector search. So a single vector search is basically like like basically just doing a k nearest neighbor search. So what that means is that if you remember here, right, in this thingy here, right, a simple vector search is just like, hey, trying to look for neighbors, right? Hey, this is what I'm searching for. How far are you? How near are you? Right? That's basically it. Now, if you're just doing a plain vector search, that's it. You're just trying to find the nearest neighbor to whatever you're based from the embeddings itself, the zero ones, those coordinates and stuff. Um, so basically, what's important there is that in your search options, you have to put in vectors, and then you have to kind of just say the size, and then how many nearest neighbor do you want to kind of like get. So in this case, I want 5, same with size as well. And then I want to select the title, content, and category of the document. So I don't need to select the content vector anymore. I just, want the content. And then within the response, which is again search client that search async, that response, I just iterate that and print that, through console.writeLine, pretty much, right? But then again, right, you still need the generate embeddings here, because the thing is your query, in this case, my query is find services similar to Azure Data Factory. And then this is where I'm going to show you where it's kind of funny, right? This is my query, find services similar to Azure Data Factory. And so what's going to happen there is that I'm going to generate that embedding, this actual query here. I'm going to convert this to those, negative 0 1s and stuff like that. And then from that, I'm going to look through Azure Cognitive Search and say, hey, who's kind of like near within this vector database or within this vector, stuff. So basically, if I run this, oh, sorry, I haven't actually initialized it yet. So, oh, there you go. And yep, I have to initialize the client. All right. So, okay, let me just restart the kernel. So, and then I have to run all again. So basically what's going to happen is that, actually, let me stop the execution. So I did perform the initialization of the service endpoints here. And then I did the, so you see in the check there that the NuGet packages actually happen. It's probably not going to stop because it's doing the vector indexing at the moment. Yeah, so like I initialized the client. Now let me just try, yeah, sorry. That means we just gotta wait to perform all the vectors. Okay, there you go. It did finish. So it did finish the registering all the indexing. So let me just double check in the Azure Cognitive Search if it didn't mess up the documents. All right, okay, so the 108 documents are still in there. So we're still safe. So now I want to perform a single vector search. Again, find services similar to Azure Data Factory. So let me run that. So what it spit out is that, hey, obviously, what's similar to Azure Data Factory is Azure Data Factory. And it's basically scoring that it's 0.88 relevant to Azure Data Factory, because it's literally, it is, right? Like, because we literally just used vectors, and like this kind of like content here, right, versus the content that I queried, it's kind of like almost similar. So that's why it's gonna say Azure Data Factory is similar to Azure Data Factory. Same goes with Azure Data Explorer, and then obviously, if you have duplicate data as well, that's something you have to be cautious about, right? Which I intended here, that even though it's kind of like not really the same, and as you can see there, it's not really kind of like copy pasted stuff. It's still gonna spit out, because again, it's not contextually aware that Azure I'm looking for something like Azure Data Factory, but in fact it just looked for Azure Data Factory and then it spits out Azure Data Factory, and that's what happened. All right, so Azure Data Explorer is kind of like relevant as well. Kind of like basically maybe because of the data and the Azure data, it's the reason, probably it's relevant. Same with Azure Data Lake, and Azure SQL Data Warehouse. So as you see, right, it's using embeddings to actually kind of like compare those two. So meaning it's actually comparing the actual services like Azure Data Factory. Yeah. So yeah, so as you see, the values, yep. So it's actually trying to create correlations with all these content vectors, based from the queries that you perform. So now, what if, what's the next phase? MJ, you're basically telling me vector database is not working. It's not, um, it's not magical. Why would I even use this in the first place? So what you can do is, one approach you can do is using vector search plus filter. So for example, find similar services, again, find services similar to that Azure Data Factory, but you want to introduce a filter. So meaning, I just want to make sure that the category I'm looking for are databases. So I'm not going to include analytics or other kind of like categories, right? So what's going to happen there is that you'll just, within the search options, you'll just have to add a filter property in there, which is again, this filter, category equals databases. So this filter, for those who are familiar with KQL or Custom Query Language, if you're doing Azure Monitor logs or like queries, it's actually the same syntax. So make sure that the syntax for the filter is correct. Otherwise, it's not going to show you the proper response. So let me open that. Let me try that. So as you see now, right, like what happened is that I showed Azure SQL Data Warehouse, which is still in the category of databases. And then I do have Azure Data Migration Service. I do have Azure SQL Database and Azure Cosmos DB. So I don't have Data Explorer anymore, and I don't have Data Factory, which is like, for example, here, because Data Factory is in category analytics, right? So because I filtered it down to a specific category, so it's not gonna spit out this not relevant content for me. So that's pretty cool already, right? Like doing vector search with filter, that kind of like does majority of the use cases already, because that means that I can use a simple vector as a database, and also doing filtering. Like I still have control on what's gonna spit out of that. And then the next thing is that, what if I want to do a hybrid search? So meaning I want to perform a hybrid of a vector search and a keyword search. So yeah, like I want to combine the traditional keyword search and the vector search. So what's gonna be different this time around is that in the query itself, right? So compare this to the previous one. What's different is that in this thing here, right? If you look at both the vector search with filter and the first one, I don't actually pass in a value on the when I perform search. So because the thing is, if I the first value in this argument is basically the keyword search. So if you put null, then meaning you're not putting a keyword search. So that's how it is at the moment. So that's the syntax when doing this. So now I want to use both. I want to use both the embeddings capability, like this query. I want to embed that into a vector embedding, and I also want to perform like a query search or like a keyword search, right? So if I try that, so again, finds, but this one's a bit different. My query is find services related to data warehousing that are similar to Azure Synapse Analytics. So if you type in this single quote, then it's gonna put emphasis on it being a keyword search. So it's gonna put an emphasis that, hey, I'm looking for data warehousing. So let me run that. So there you go, right? So what happened is that Azure Synapse actually kind of like became the number one score, mainly because of data warehousing, right? But also at the same time, I'm also looking for similar to Azure Synapse Analytics. So that's why it's kind of like funny because again, Azure Synapse Analytics is again similar to Azure Synapse Analytics because it's the same thing. But because I mixed it to keyword search, now I'm doing both data warehousing and Synapse similar to Synapse Analytics. So that's why but in fact the most relevant for me is probably Azure Data Lake Analytics or Databricks, right? Um, but then again, right, like the thing is it prioritized the data warehousing kind of like keyword. So that's kind of like again one caveat if you're trying to do hybrid keyword search and vector search, right? So now, MJ, again, this is like not progressing forward. So what do I do? So that's why I think this is where the hype is at the moment. What if we do semantic search or semantic hybrid search? Like, meaning instead of just looking for big data processing, I'm just gonna look for, and I'm gonna use NLP or machine learning to kind of like, hey, anything that's related to big data processing, you create that contextual relationship for me, and I'm gonna use the embeddings vector database to store this search. So yeah, like that's what I want, like basically I'm not really looking for like to like big data processing as the word I'm looking for or set of words I'm looking for. I'm actually looking for semantically similar to big data processing, right? And so my query is now find services that are used for big data processing and are similar to Azure Databricks. So if I try that, so first again, generate embeddings. So what's different this time around is you'll see a bunch of things in this search option, right? But the most important part is that you have to put the query type as semantic. Okay, you have to make sure that your query type is semantic, and this one is in preview at the moment, so it's not yet publicly available. But yeah, like that's the most important bit that you have to put in there. You have to make sure that the query type is set to semantic. So same thing. Now you perform a response. Sorry, you perform a search within passing that query, and again it's hybrid, right? Like built from this, but I want to use semantics as well. So what's gonna happen is that I'm also gonna instead of just highlighting the title, score, and content and category, I also want to show the caption highlights, meaning like what actually was semantically similar, right? So I just want to show that to you. Like this is gonna show you like this is what's been captured that's semantically similar. So if I run this, so if I run this, so what actually spits out is first, again, let's just recap, right? My query is find services that are used for big data processing and are similar to Azure Databricks. So if I look at HD here, first thing that kind of like popped out is HD Insight, mainly because of the big data workloads, right? But the thing is, although it's a because we use the hybrid search, so it's still search resulted into saying big data and processing, right? And then the thing is, in the highlights, it says Azure HD Insight, right? And then there you go. Yeah, HD Insight. That's kind of like the highlight. The insight is the highlight in there. Then the Azure Event Hubs, funny that it actually returned Azure Event Hubs. So the thing is, the reason why it returned Azure Event Hubs is because of this real-time data ingestion service, right? And then the thing is, although I didn't perform a category filter, but the thing is, it was contextually aware that because I'm doing real-time data ingestion service, and this kind of like millions of events per second. So what happened there is that it made some contextual awareness that, hey, this also means big data, right? So this is the power of this semantic search. Like I don't actually have to type in big data processing, but then what happened is that it correlates that these millions of events per second is the same as big data processing. So that is the power of this semantic search, right? So that means you're actually using this capability to kind of like create, the one using vector database as a vector embed store, but two, you're actually using NLP or machine learning to also look for similarities and contextual similarities for your query. So what this means is that later on in your ChatGPT experience, right, like performing a lot of this search and stuff like that would allow you to actually like create more contextual awareness of your inquiry. So that means that later on, if you have a very very big knowledge base of information, maybe it's not just an FAQ anymore, it's a very big knowledge base already. Then if someone tries to type in a question, you don't actually have to use keyword search anymore. You might actually use mix and match of different things, and maybe you want to use contextual awareness for that as well, so that when probably someone looking for emergency, then that means that emergency also equals um, like urgent or something like that, right? Like, so a lot of those different kind of, it's not just about synonyms, but it's also more around like contextual similarities. So with that, that kind of like ends my topic. Um, but then if you want to learn more, pretty much like just go to Microsoft Learn, Azure Search, and go for vector search in particular and semantic search. Those are the two things you probably want to learn more. And then there's a ongoing cognitive search vector PR samples from Azure, which kind of like highlights a bunch of these capabilities. And I'll be uploading this as well, this notebook for others to use in the future. But yeah, that's pretty much it. So I guess I still have time. So if anyone has questions, Marilag, so that's it. You're on mute.
As always, I was just saying, wow. I think my brain is exploding, and not just trying to understand everything that went through that notebook, because there's a lot of information, but also it's exploding with so many ideas. Definitely helpful. Definitely inspiring for some of the use cases that I'm also working on with the different domains that my team is working on. I really like that part when you talk about hybrid search, and then
Mm.
when you went down into the semantic search, which I know you mentioned is still on preview, but that's where you really see the huge impact of what you're trying to do here, right?
Yes.
uh, I think I'm just curious, as a software engineer, maybe this is not very specific to the topic, but just like the part of testing your models, your design, your prompts. Do you have any insight on how to do this? Because it sounds like lots of permutations. How can I guarantee that when I design this query and then modeling, that I'm actually really getting into the right results that I want? Can you
Well,
set up some parameters and stuff? Yeah. Is there a
if I
way?
do have the answer, Marilag, then that means I should be working for Google or Bing, because the thing is, again, it's the ever challenge, right? Like search has always been a challenge, even the early .com bubble days, even until now we just have like basically what Google did, they introduced this AdSense, or like how relevant are you and stuff like that. And then now we have another technique, which is semantic search. So like the question still remains, wherein like, is this applicable for your use case, right? Is this applicable for everything? Is this gonna do I need just semantic search? Do I need to do mix of hybrid search? I mean, full text search, or plain vector search, or maybe I also want to do fuzzy search. Do I want to do a graph traversal search? So still, it's still the same question, right? Like, so it's still it's still same questions. Now we just have a new contender on an approach.
Yeah, but definitely worth looking into, because we've worked a lot with graph databases, for example. So we understand the concept of like graph traversals, and everything can be expressed in in arbitrary relationships, so you could really do understand where the search results come from, because you can see it in the model. It's very mathematical, it's very logical to see this node connects to this node, and if
Yep.
you traverse it, you have like a path, and you can compute that. So it's kind of easy for human brain to understand and also optimize your search results, because then you just make a better model. But with a little bit with the vector databases, this kind of proximity, and then put the semantic search concept of how did the machine find out that when you mention like large data processing, that actually means big data. That's sort of a black box from our point of view.
Yeah. Yeah.
So what I'm getting into is like, I think, where would you start? Would you start just with playing around with, I think we've played around a lot with keyword search, that we understand. Would you just
Yeah.
start
Yeah.
playing around with vector search first, and then optimize it using semantic search?
Correct. Yes, I think that's the way to go, right? Because again, most likely, in particular for use cases that again, not just like to like, right? Again, if someone types in something, and then if that kind of like specific set of words doesn't appear to your database, then game over, right? You're not actually showing something anything similar. But if you want to use vector database, maybe it's not just about the word itself, maybe how close it is in terms of the set of words, and then mix it with semantic search, which kind of like enhances using algorithm this time around, right? Like you're now relying to NLP to do that thing. And the thing with NLP is that it's probably language specific as well. So that means that if you're doing NLP and semantic search, then that means it's a language to language basis. So that means you need to have a mature NLP capability or for other language. And so that's kind of like one of the caveat as well of doing semantic search using NLP.
Yeah, certainly. And you mentioned, yeah, you have to do it in a specific language, but you also have to consider the nuances in that one same language. It's like the English language, there are a million ways of expressing the same thing. And being able to understand what the user really means when they say this one, with, let's say, with a Filipino way of saying it, of expressing it,
Yeah,
versus
the
with a British
slang.
one of saying it,
Yeah,
it is super exciting. That's what I wanted to say. And there we have no answer here on this meetup. I think the only answer is that we really encourage you to try. How do we try out this? Like, first of all, there's a question of, yeah, you mentioned that you're gonna upload the notebook.
oh yes, I'm
Would
gonna
you?
upload the notebook. Yeah, wait a few more minutes after this meetup. I'll upload it to my GitHub. It's at MJTPNA, and
Okay.
then I'll just put it there.
Yeah, because then I'm gonna post it on all the channels where we have the live. I think we have it on LinkedIn and Facebook and YouTube. So if you guys are watching from any of these channels, we'll put it there. If you're a member of Azure User Group Manila Meetup group, or in meetup.com, then I will also post the link there, because I would also need it. So I'm gonna chase you that for that, MJ. I
Yeah,
said, okay, maybe I cannot process. I get the G's of it, but I know that the only way to really understand it is to get your notebook, read
yeah,
the wonderful notes that you have written there, and then try to run it one by one. Is it, does it
yeah.
cost anyone to just try this out?
Well, yes, because as part of the notebook experience, right, you need to set up a bunch of stuff, right? Like you need to have Azure Cognitive Search, you need to have OpenAI and stuff like that. So this is kind of like one prerequisite to run this notebook at the moment. So yeah.
Certainly, but this can give you a very good case, if you're working with this and you want to talk to your colleagues or to
Oh
your
yeah, yeah, yeah. I
manager,
mean,
right?
yeah, it's a good investment. I mean, you don't have to spend millions or thousands already just to begin with, right? It's just a bunch of cents per queries and stuff like that. But yeah, but yeah, like the thing is, one thing about all of this thing at the moment is that there's no offline version of this thing yet, because one, this text embedding model capability. Why do you want to, load that model on your machine? A very powerful text embedding capability. Same with OpenAI, LLMs, like terabytes and terabytes of and stuff like that. So that's probably one of the reason why you want to use an API for that.
Yeah, so someone like our friend here, Torquil, he also mentioned
Oh
that you
yes,
have to
yes.
first apply for Azure OpenAI. Yeah, and yeah, we did that, and you can, and then there is a process. You just search for Azure OpenAI. It's like a form or approval form. But then again, if you work for an enterprise company who probably already has Azure OpenAI on and some credits for using cognitive search, and you don't want to complicate things, take this notebook with you and show it to a decision maker and say, hey, I just need a couple of hours just to try it out, so for us to explore what we
Yeah,
can
like
do with
what you
this, you know.
literally what you're gonna do is change this Azure JSON, right? Like obviously whatever data set you have, and then create your own indexes. And that's it. And then now you try to perform this search, and and then there you go. That's the demo. You don't need to create a whole app anymore. It's just a bunch of like search.
Yeah, and thanks for doing this for us already, MJ. Mean, this is a really good head start, and I'm pretty sure a lot of people can benefit from this. Okay, just one more question before we end because we're out of time. You mentioned it a little bit on your talk, the ETL process. I know this is
ah,
we should probably have a different session just talking about
yeah.
ELT. Sorry, you said ELT, not ETL. Those are two different
ELT,
things.
yeah,
ELT, right? Because at the end of the day, this data that you're showing now is the heart of it all. This is what's going to get indexed. This is what
yeah.
we're, what's going to get searched. Any It's like, do you suggest starting with a very small data set and really, when you say discard a lot of things, or you might, if you do that, you might be in for surprises once you load the real data set. So
Uh,
you're the data expert, not me, so I wouldn't know what to
Right.
do.
Well, that's the ever question, right? Like, how clean is clean? How dirty is dirty? How bad is bad? And again, it all boils down to scoring and how you want to scoring. In this case, scoring search means like how relevant is that for you, right? But then again, right? The well, a couple of things, right? One is, for example, duplication. That's kind of like easy. Like, if you don't want to use duplicates, just do the process of removing duplicates. Second is sanitation, right? Like for example, like maybe sensitive information, PIIs and stuff like that. Don't put it in there, right? That's kind of obvious already. Third is like again, what is a good subset or what is a good representation of your whole data set? Because maybe you want to use your whole data set, your whole terabytes of data set, or maybe you don't want to. And that's what that's why it's more like a data science problem really, and how do you sample that data set that's relevant for you, and then once you actually deploy this in production with your own index of plethora of data, now you'll see. um, so it's the same problem again, Mary, like it's the same problem as where we are at the moment, like how relevant it is for you, how what is your definition of clean, what is dirty, what is bad, what is good. You have to define that yourself. Yeah. Like for
Yeah,
example,
so
I intentionally created Azure Data Factory here as duplicates because just to show you that if you don't clean this, then that means that you'll have two results showing Azure Data Factory, which could actually mean just the same thing.
that's a very good point. So I think I have an idea now of the next topic. So back to basic, like reminding people about the whole complexity of ELT, just so we get to this point. And then maybe it would be nice to have another session around the decision making or the decision parameters for picking the right data platforms for storage, for
Ah,
persistent, and for indexing. Is like with vector databases and all vector search, and you showed all the other alternatives outside of Azure. A lot of people would be so curious to know which is which, but that's for another day.
yeah,
And if you can help us with that, you're welcome to join us again. Or if you know anyone who can recommend, who can have who talks about this stuff, and for you
yeah.
others watching this, yeah.
My guess, all right, I'm just gonna guess, right? My guess is that it's gonna be Postgres and Redis who's gonna win this data.
Yay! I use a lot of Postgre and Redis at the moment, so happy to hear that. Maybe I'll
Yeah.
have a look at the and play around with the data with that as well. But we
Yeah, the
use
thing
also
is,
Cosmos DB, but it's not the. Oh
yes,
yeah,
yes,
these are the non-Azure vector
yeah.
databases. Cool.
So
Yeah.
yeah, because the thing is, yeah, I mean, Cosmos DB is obviously one of them, but yeah, my gut feel is because they're so specific for vector at the moment, they don't have the market share of these Postgres users already in Redis, and
True.
like it's just a different data type, data format. Just like SQL Server back then doesn't support NoSQL or documents, now it supports. People just don't know.
Yeah.
You cannot store JSON and all those different stuff as well, but again, people don't know. But same thing is gonna be happening for Postgres Redis. Is that it's just another data structure that it's gonna support.
All right. So, well, thank you for extending a little bit. And I know it's also late there in Sydney, and I can hear your kids calling for their daddy. So I'm
Yeah.
not going to hold you back anymore. Thank you very much for joining us today. And see you again, maybe in the next sessions. And if you're interested in joining our group, Azure User Group Manila, you can find us at meetup.com. Or if you're interested in sharing your knowledge, please. Yeah, reach out. I'm on LinkedIn. Just look for me, Marilag Svenvig, or one of my co-organizer, Joanna. She's also there to help you. So we're in Facebook, Meetup, and LinkedIn. Thank you so much. Thank you for your time. Thank you, MJ.
All right. Thanks everyone. Bye bye.
Bye.